The last property here basically just says you can add separate areas together and combine it into one area. So integral from a to b f x dx is by definition what I've written each time. It's a limit definition function at the sample point. There's the height of the rectangle. And I'm going to write the expression for the delta x because I want to manipulate it here in this problem. Okay, so there we go. There's delta x. There's a definition. And what we can do here is we can slip in another value between b and a in a sense. Okay? Now, numerically, it doesn't have to be. It doesn't have to be that we're splitting the interval a to a location and that location to the end. This value can really be anywhere and can be anything. And you'll see from the algebra here why that's the case. And it is b minus c plus c minus a is of course the same as b minus a, right? Negative c plus c does nothing. So even though a lot of times conceptually, when the property I'm about to illustrate is used, you're kind of thinking about this number c being between a and b. It's like a to a certain point and then that point onwards to the end of the interval. And you can add those two areas together. But it doesn't have to be that way. The value c can really be anything, not necessarily between a and b. All right, so now we can split this up. The limit, and use the property of summations and limits again to get the desired effect. So f of xi star. So if I just split this sum into b minus c on n, I have to use a bracket or something, plus c minus a on n, something like that. But this is another sum in here, so I can distribute the function over this, of course, it's just a regular product. I can distribute the summation over this, because summation has that property, as we discussed before, and the limit as well. They all have this distributive property over a sum or a difference. So we can go ahead and do that, and we'll have the limit sum f of xi star times b minus c on n. Plus, I can fit it in here, fxi star of c minus a on n, right? A new delta x expression. All right. So we now have two different integrals here, and they have different intervals of integration now. Right? We start out with just a to b. Now we've got one that's going from c to b. We get one going from a to c. But they're still just standard definitions of integrals. So we can replace these with the integral symbol. First one is from, again, c to b. c to b f of x dx plus, there's a plus right there, integral from a to c of f of x dx. Now I'm just going to write this, I'm going to switch these two. Again, integrals, definite integrals are always just numbers. So this is a number and this is a number. So the order in which I add them does not matter. Just switch the order. I'll do this for a particular purpose here. A to c plus c to b. So now you kind of see why I was saying that it looks like c is between a and b, literally in terms of magnitude. It doesn't have to be the case, though, as I was saying before. It wouldn't matter what you put in here for C. This algebraic statement would always be true. It is not the case that C must be specifically between the A and B on that interval. It doesn't matter. So this holds for all values A, B, and C. And that's our last property.